Welcome to AASHTO Resource Q&A. We're taking time to discuss construction materials testing and inspection with people in the know, from exploring testing problems and solutions to laboratory best practices and quality management. We're covering topics important to you.
Welcome to AASHTO Resource Q&A. I am Brian Johnson. With me is my co-host, Kim Swanson. And we have some special guests, John Malusky and Ryan LaQuay.
I can't believe you did that, Brian. We just had a conversation about how we're going to pronounce our A's, and I did not agree to that pronunciation. But I'm glad everyone can be here for today's episode.
Yeah, so the reason, in case you're wondering why I did that, today's episode is about the very popular wheel tracking test that is used throughout North America and elsewhere. I assume Germany as well. It is called the Hamburg wheel tracking test. And the reason why we're talking about that today is because it is a new addition to the Proficiency Sample Program. So that's why John Malusky and Ryan LaQuay are here with us. And what we were talking about is when you go to a meeting, you often hear people say either Hamburg or Hamburg. And we're going to call it, just so everybody knows, I know we have some international listeners, we're going to call it Hamburg because we're American and that's just how we typically say it. So no offense to our international listeners about how we pronounce Hamburg or Hamburg. But I want to get that out of the way right up front so it doesn't become an ongoing issue on this podcast. Does that sound good, John?
That works for me, Brian. Thank you.
I have to admit, the composure was excellent. I don't know if you're watching this, but you guys maintained pretty good composure through that introduction. So congratulations. What we want to talk about is the Proficiency Sample Program, not just because it's a new sample, but because of how we prepared it this time. So, John, why don't you give us some background on how we got here? Why did we add this sample program to our system?
Well, this has been probably a year to a year and a half in the making. Back in, I'm going to say, the spring of 2023, during our technical exchange, there was a discussion with the Administrative Task Group, which is AASHTO Resources oversight of the state DOTs, and they bounce ideas off of us and proposals and recommendations. And one of the recommendations was to investigate the plausibility of having a Hamburg Wheel Track Proficiency Sample Program. So that's kind of where it originated way back when, a year and a half ago. And then throughout the course of that time, Ryan, myself, and the Proficiency Sample Program crew spent a lot of time having discussions, doing some research, talking to plant producers, other people such as NCAT, DOT staff, just trying to figure out a way to make this work and do it in a reasonable fashion. So, been a little while.
What were some of the challenges that you encountered while you were trying to prepare this?
We talked with a number of different people in the industry, DOTs and whatnot, where they were doing similar programs, and they had a number of issues. The one big issue was making the quantity of samples needed for their participants, because with Hamburg, we're doing Hamburg. You need at least 4, compacted samples or slabs, whatnot there. So we're looking at, for us, we put in about 10,000 grams of material, and that needed to be pretty darn similar across the board for the whole thing. And way we've done that in the past for our mixed samples is we hand batch everything, hand mix everything. So doing that, 200 times over, because we have about 160 labs in this program, plus our extras and whatnot, not quite feasible. So we had to figure out a better way to do that. So we asked around to these other programs, had a variety of different methodologies for how they got their materials. So we had to kind of go through that and see what was feasible for us and what we could actually manage.
All right. So when you did the first attempt at this, can you give us some background about how that went?
We did a little pilot with, was it 4 3 DOTs, 4 DOTs.
Yep.
So we talked to a local manufacturer, got some slant mix, batched it out the way that we thought we were going to do it for the production here. And the way we did that first was we sent out 2 boxes, sample A, sample B, and we'd have them then batch down to their 2 individual specimens out of that. Some confusion happened there on the batching and which sample's which. Is it sample A the top sample, is sample A the bottom sample? So we got that out there, had some confusion on the instructions, and then whenever we actually ran the samples, they blew apart. So it was 3,000 passes or so.
Yep, I think that's right.
Just absolutely exploded. So that one got a quick X of not a viable sample.
The one thing that we noticed right from the get-go is that we're already seeing some challenges and variations just with preparing the material itself. Ryan and I compacted probably 20, 30 different pucks in our gyratory compactor in our facility to try to hit the correct specimen height of the 62 millimeters, but also get the right air voids. And, to the industry, people who are doing this, right, that's pretty common and seems like it'd be a pretty easy thing. But one thing that we realized is that our compactor is completely different than other compactors. There's so many different makes and manufacturers and models out there that there appears to be quite a bit of variation. So when we're looking at some of the data in this round, we're actually asking for things like the number of gyrations it took your gyratory compactor to get to the 62 millimeters, just because of some of the variation that we're seeing. Like our compactor specifically, it's an older Pine 125X, and it compacts from the top down. And it was taking us, like specifically with this mix that we used for the round, I think it was in the low 40s. Correct me if I'm wrong, Ryan. You did the last final one. I think it was high 30s, low 40s.
Yep. For
us to get to the 6 to 7, I guess 6 to 8% air voids at 62 millimeters of height. And we've seen other laboratories with the same mix, different compactor. It will take them 75 to 90 gyrations. So just immediately off the top, we're seeing some variation with the compaction effort itself. So that was probably one of the biggest things we've tried to overcome and figure out from the get-go. Ryan already kind of mentioned the segregation issues that we may have with the mix. We actually spent quite a bit of time talking to the Ministry of Transportation of Ontario. They have a laboratory program, sample program, kind of like we do, and huge thanks to them for their support and help with this. But the first thing that they immediately told us is do not go with any mix over a 1/2 inch, 12.5 millimeter mix because of segregation. They were shedding some light on what they do. They actually kind of do a stockpile type sampling, and they advised against that due to segregation, and they provided their procedures and protocols. So we kind of shied away from that just because of their recommendations. But it's been interesting. So I'll say that. So the design was just an initial challenge itself. I think we went through 4 different mixes or three different mixes.
Yep.
Until we targeted the one for the round with multiple trials with different DOTs. So it took a little bit for sure. I think that's why it took us probably 18 months to get it going.
Yeah, that's great that you spent that extra time to get it right before you sent it out. So I think that should give people some confidence. What other data are you collecting in this sample other than the gyrations?
Well, let's pull up the data sheet here and look at everything we've got. So we're looking for compaction device manufacturer and model, the average record temperature of the mix prior to compaction, average time from sample being poured in the mold till compactor applies the load, number of gyrations as mentioned before. Then we're going to have laboratories determine the bulk specific gravity. We will be providing them a maximum specific gravity, and then they'll calculate the percent air voids. And then when we go to the Hamburg, we're going to ask for the wheel track manufacturer, whether or not the root mean square error has been verified, and then the rut depth from 5, 10, 15, and 20,000 passes. stripping inflection point, rut depth at stripping inflection point, and number of passes to failure.
I don't want you to give away this answer.
Sure.
But I assume you have an expectation of how many passes to failure on this sample, correct?
Correct.
We do.
So
Yep.
you'll be now this is our proficiency sample program, so it's gonna the ratings will be based on the average, but you have at least an idea. So what should anybody expect to be able to complete the test as they normally do and not get a failure?
So for this round, I can't say we're 100% certain as to what's going to happen. The other trial runs that Ryan and I had talked about, the pass count was substantially low. You know, our first one, we used a mix that I believe was around 30% wrap that I think failed around 3,500 passes. The second one was a standard virgin mix with no wrap at all. And I think that was around 7,000 passes, Ryan.
Yep.
And this one, from the data that we've seen, I'll say this: you can anticipate it to be over 10,000. So we were hoping that many of the state specifications that are out there now are recommending a 10,000 minimum pass count. So our first goal was to try to at least hit that with the design. So we're anticipating that it will make 10,000 passes. We can't guarantee that on the average and what the normal distribution is going to look like and a standard deviation, but we're hopeful that it goes beyond 10,000 passes. The one thing that we had a discussion with some of the industry experts is, do we want a sample that doesn't fail? And our answer to that was no, because if we don't get a failing sample at some point into up to that 20,000 pass count, then people can't determine a stripping inflection point as accurately, because you're getting much more interpretation rather than just getting a failure and being able to plot that. So yeah, it's been interesting to try to figure this all out and learn. It's a lot of effort behind the scenes went into this. To be honest, probably the easiest part was the production. Once we got this figured out, had some discussion with the crew, the packaging was pretty easy. So
before we go too far, I don't want to forget this. I want to go back to one of the comments Ryan made earlier. In case anybody doesn't know this test, can you please clarify when you said that the sample explodes? We're not sending out explosive materials, correct?
Yeah, we're not using gunpowder as mineral filler. No, it's basically the rut, the wheel as it comes through the sample shoves it all out to the side, and it's not nice and clean. It's like you take a heavy weight through mud and just kind of push it all out to the side.
Yeah. So it collapsed. It collapsed and fell apart. So I want to make sure people understand that who don't know the test. I'm sure the people who know the test kind of had an idea of what you were saying, but those who don't probably were very curious about that comment. Let's get back to the preparation of this sample. So if you know about our proficiency sample program, you know that we prepare everything so carefully. We weigh up all the aggregate to the nearest tenth of a gram, and it's got to fall within a very tight range. And we add the asphalt to the tenth of a gram. And we're so precise in our measurement, and we're so consistent that we come up with these really good samples that are repeatable, able to be tested in a repeatable manner and come up with some good data. The big change here is that we didn't do that this time. Not that we weren't careful, but we did it a little differently and faster and more representative of what people do in practice. John, can you take us through your experience in developing this methodology this time?
Yeah, the biggest thing was what we've kind of already touched on a little bit, discussing with the producers and suppliers and other industry experts. And the main issue is segregation. That was our biggest concern when we packaged this material. So we didn't want to stockpile sample, right? We didn't want to just have a mixed truck come here and dump a pile on the ground or dump a pile on a stainless steel sheet that we had like release agent on it, because obviously when you dump in a pile, material rolls, and that roll is segregation. So after a lot of investigation and discussion, we decided and settled on the use of a hot box trailer, which is basically a truck that's just got a diesel burner in it, heats the sides and base, and is typically used for pothole patching. But that was a way for us to get enough material, keep it warm, able to be workable, and we felt like we would keep it consistent. And the other major recommendation was I kind of already mentioned particle size. We started out with a 3/8 inch or 9.5 millimeter mix. I think the asphalt content was just over 5% to try to keep a little bit more liquid or keep it a little bit more viscous. So we had that kind of flowing capability to not allow it to segregate. Just as if we were to package a fine aggregate or a sand, we would keep things in a moist condition to stop, fine separation and particle separation. So just something like completely different. It actually took us probably 4 months to find a hotbox trailer itself. We could have bought a new one, but given that we were only going to need this for essentially one day, we didn't feel that it was justified in the purchase. So we contacted multiple suppliers. I was at a trade show or two talking to different people to try to get one, and we were fortunate to find a company that rents them, and they are only about 40 miles away from us. So we actually really lucked out. They had availability. We actually rented the trailer for a month to make sure that we had it, even though we knew we only needed it for a day or two. Plus, we wanted to account for things like the weather. We wanted to have the truck here on site, and in the event that we had a rainy day, we could hold off and not have to package and try to do our best to make sure that all things were accounted for. Even a ton of effort even went into the box size that we use for the quick release boxes. Ryan had mentioned before that we were going to take a larger sample and have the laboratory split. And then after the confusion that we so pumped into the whole program by having horrible splitting instructions, we made the decision and alternated our course to send out single samples for each portion of the wheel. So the front of the wheel, the back, so for those of you who don't know, the Hamburg specimens, there's 2 pucks in each side of the machine, a front and a back. So for the left side of the machine and then for the right side of the machine. So that's why Ryan had mentioned we had to send 4 samples. So rather than sending 2 boxes and have the laboratory split to get the 4, or 1 gigantic box and have the laboratory split, we went with 4 individual boxes. So we had to adjust and contact our supplier for the quick release boxes, and had probably 7 or 8 different sizes of boxes sent here and tested them to see how they would split and what would fit and all that good stuff that goes well beyond just putting rocks in a box.
Mm-hmm. Actually, we got the boxes and we took some just random mix and also went and checked our different scoops to see what would work out. So we just heat up a bunch of stuff in the lab, brought all the scoops together and try to figure out like, all right, this scoop can get us to about 50% capacity, so 2 scoops gets us 1, or this one gets about 2/3 of the way, so 1 full scoop and a little partial. So that was a solid morning that we spent just trying to figure out scoops and boxes and how we'd approach that.
Did you identify the individual sample boxes to tell them where to put them in the? So you actually did label them?
Yep.
Okay.
Yeah.
All right. That's what I thought you were saying, but I want to make sure.
Yeah, with the sample labels will say, sample A front, sample A back, sample B front, sample B back. So the laboratories are hopefully putting them in the specific location for the machine, and that's following all the way through the compaction effort.
Yeah, so the segregation issue, you mentioned the challenges that you would have with a pile. Obviously dumping from the truck to the hot box trailer is going to potentially have some segregation, and then sampling out of that, I would think, would also have a risk of some segregation of the particle sizes. How did it look when you were actually getting your samples out of the hot box? Because visually you'd be able to see if you were experiencing some segregation. What did you think?
Yeah, no red flags during the production process. Everything looked pretty well, homogeneous. There wasn't like big clumps of 3/8 material or big clumps of fine material. Everything seemed pretty well blended. We are actively right now, so I was late to this recording, testing that to verify that it was all properly blended and homogeneous.
Oh, so what are you doing to test that, Ryan?
So we are doing a successful extraction, so we're burn and gradation. So we're probably be done early next week, and we'll have our final data on how well this turned out.
And what does success look like in that result? What
Sure.
What are you hoping to see?
So we're going to look to have, basically the distribution of materials, distribution of asphalt content to be pretty darn close. So we are like for our in-house blended samples, we have some tolerance because human error and whatnot. So we're basically looking to make sure that we're still within that spread of tolerance, also looking against the standard for repeatability on that. Just seeing that everything is generally the same across the board. So they're not going to be perfect, but we're trying to be as close as we can.
Yeah, one thing I do want to go back to and kind of add a little bit of clarification is, Brian, you had talked about using a truck to dump the truck into the trailer. That's not what happened. So we actually, with the trailer situation, our crew took the trailer directly to the batch plant, and the batch plant just dropped the prepared mix out of the hopper right in. So we eliminated one potential step of inhomogeneity, and it seemed to work out. Like I said, I think the only thing that we did notice was after a little while, some fines and asphalt did stack up on the scoops. But after so many, maybe Ryan, every 35, 40 minutes, we actually swapped scoops out to keep our scoops clean. Mm-hmm. And then the ones that were dirty and had fines built up around the lip, we cleaned those off, to try to do our best to stop any kind of segregation. So, like I said, we put a ton of thought into it to try our best, and we're going to see what happens with it.
Now, there are other wheel tracking tests out there other than the Hamburg. How did we get to only have a sample program for that test? And is there any thought to possibly adding or expanding this program to include other wheel tracking or rut testing tests?
Well, so I assume we got here because this is the ATG's biggest target whenever they brought it up to us. It's becoming more popular for specifiers. They want to have data on this. That's something that we can get out of this, hopefully. But yeah, this is also our first toe in the water. If this goes well, we're going to look at all the rest of the balanced mix design programs or test methods and kind of develop out through there.
Yep, that's correct. We're looking at other methods. Some of the other things that we've already had suggestions for are indirect tensile strength and tensile strength ratio. So they're kind of the other two that are on the radar already for this. But we'll see what happens. We're going to see how it goes. Hopefully the homogeneity and stability data come back and are reasonable. The one thing that's kind of tough is we've always benchmarked our homogeneity off of our previous samples. So all the individual batching and hand mixing. So it's going to be a little bit more challenging, we believe, for us to hit some of those criteria because it's not prepared the same way. So we're going to have to evaluate the homogeneity and stability from a different benchmark, which is going to be a little bit different for us. So we'll see. I think we're very optimistic about the way things went, and we'll see how it goes as we continue to test the material and evaluate the data that comes back to us.
Yeah, so if things go well with this one, with the way you prepared it, because I know it's way less time and effort to prepare a plant mix sample than it is for the individually mixed and batched samples that we typically send out. Do you think you're going to expand that methodology to the other asphalt mixture sample programs?
If we do see success with this and the materials appear to be stable and homogeneous, and the data that Ryan and our other laboratory technician generate, if it looks good, we will anticipate moving this type of production into our solvent extraction sample. It will help alleviate some time constraints that we experience. And if the mix is consistent, then we'll go ahead and progress in that way and move to that kind of packaging event first with that sample type. And if it continues to show promise of good, consistent data, we would consider making a change to our gyratory program. And instead of having laboratories do the batching and mixing and all that kind of stuff by themselves, we would consider just a essentially like a QC type program where laboratories would get boxes of mix and simply compact specimens and then do the typical volumetric testing on it. And then kind of a branch off is the way that we set up our current gyratory program with sending virgin material to laboratories to test. It would kind of go to more of a mixed design program where we would send specific batching information, but then the laboratories would be responsible for testing and providing data for all the components of a mixed design. So aggregate specific gravities, angularity, then your obviously your volumetric properties as well, GMA, bulk gravity, the stone bulk gravity, the pucks, the asphalt max gravity, VMA, VFA, dust to binder ratio. So it would be more of an encompassing program for a facility who's specifically doing mix design itself, rather than just QC checking the mix to make sure that you're hitting your volumetric properties. So there's a lot of opportunity to make some changes to the program and try to streamline the process a little bit for us and the facilities and the labs. And we're just going to see how it goes. We got to, as Ryan said, we got to dip our toe in the water first, and this is it.
Kim, do you have any questions for them?
I do. I mean, that seems like a lot of potentially exciting things happening if this, based on the success of this round. We also have some other new samples in the proficiency sample world that we're doing. So I don't want to spend too much time on it, but can you go over just what's new coming up currently or coming up in 2025 that are new samples?
Well, we'll say everything within the next 6 months. That'll cover it all.
Yeah.
Sure. So end of this year, we are doing a winter maintenance product sample. This was brought to us through Clear Roads and the DOTs. Basically, this said, we have our qualified product list, but we want to make sure that the testing laboratories are competent in what they're doing. So we're trying to do that with a liquid component and a solid component. Enrollment is open now, still open. We have it open till middle of November, trying to get as many people as we can into that one. We need more. So if you're listening and you have a chem lab who does this, send them our way, please. Thank you. And then in the beginning of next year, we are splitting out the soil and chemistry and corrosivity tests out of the soil sample. So this is basically something that was already in the soil classification compaction sample, but we weren't able to modify the soil to have good results out of it. So we're pulling that off to the side, keeping the classification compaction sample as it is, and making this one actually a viable testing sample.
When we get to those points, I think we'll have to have other podcast recordings to get into the weeds like we did today on the Hamburg, so that people can learn more about them precisely. But back to one thing I do want to address on those, though, the winter maintenance one. So far, just so people have an idea, what are our numbers looking like now?
We have 6 participants.
6 participants is a very sad number, because we need more data. So the value of the program hinges on the number of participants, right?
Yeah. So our statistical analysis will start to fall apart once we become under 17 participants. So that's our minimum benchmark we're looking for.
So we've got a ways to go here. And
a little bit.
If you are far enough from the equator enough to care about this type of activity, winter maintenance, no matter where you are on the planet, consider signing up for this program, because I'm sure that people all over the world are interested in this and could probably benefit from the results of this program. So it doesn't have to be just DOTs or their subcontractors that participate in this.
The program actually has a lot of additional potential, not just for I'm going to say physical properties of the brine solution and rock salt. Right, one of the big things we're obviously looking at is particle size and distribution of the rock salt, and how the gradation is met, so would come out of the back of a truck appropriately. But one of the other components that I think Ryan and I didn't even realize that was involved was the chemical component of the brine solutions. Many of the standards that we haven't included in the program yet because of I don't want to say a ton of interest, but maybe the interest isn't, or the idea is not out there yet. But for wastewater, right? So when all of this brine solution gets put on roads as a treatment, that eventually gets washed into the environment. So a lot of the testing is for things like lead, arsenic, other heavy metals that are out there. So it's kind of also a little bit more of an environmental side as well than just simply construction materials as we're used to. So this is also another little toe dabble in the water of a different type of material than we've done in the past. But basically because of interest from DOTs and members. So we'll see how it goes. But yeah, if you agree with what Brian said, if you have the opportunity to sign up, please do so, so we can get some good data out there.
I don't have any other questions for you on this topic, Kim.
No, I think everyone covered everything that I had questions for. So, I mean, I'm
and
happy.
Then some.
Yeah. I mean, I'm not gonna lie. Some of this was way over my head. So that is why I stayed quiet most of the episode. But I want to thank you both for taking time today to talk about this and share about the new Hamburg Wheel Track sample. And then I do look forward to hearing about some of the other new samples as we get closer to those.
Yeah, thanks, Kim. I think one thing we should definitely consider is a follow-up to this once we do have the data back and we can analyze it a little bit more, and just kind of give a little bit more of a broad perspective on what we saw out of the results rather than just, Z-scores and ratings.
Thanks again for being on the podcast. And if you are only listening to it, I want to let you know that we are now also showing this on our YouTube channel. So there is a visual aspect to it. So, and you'll notice that today is it's Aloha Friday here at the Johnson household. So I've got my Aloha shirt on, and you three are clearly celebrating AASHTO Resource Friday because you have your AASHTO Resource branded polos on. And and I would also say that this is highly unusual to see all three of you wearing one of those shirts. So it's not like you normally show up in an AASHTO Resource polo. So that's pretty funny. We hope you enjoyed the episode today, and tune in for the next one.
Thanks for listening to AASHTO Resource Q&A. If you'd like to be a guest or just submit a question, send us an email at podcast@ashtoresource.org or call Brian at 240-436-4820. For other news and related content, check out AASHTO Resource's social media accounts or go to ashtoresource.org.